My dear students, in this video I am going to define continuous random variable and probability density function. See, in the previous video we have defined what is that discrete random variable, and for that discrete random variable we have defined the probability mass function. In the case of continuous random variable we are going to define probability density function, which is the difference. For a discrete random variable, it is called probability mass function. For a continuous random variable, the function f of x is called a probability density function. That is the difference. So, continuous random variable is nothing but, let us be a sample space. The random variable x from S to R is said to be a continuous random variable if it has uncountable number of real values in R. In the case of discrete random variable, the real number set, range set consisting of only countable number of elements. For the case of continuous random variable, the range set are consisting of infinite number of elements, uncountable number of elements. That is the difference between discrete variable and continuous random variable. And for the probability density function is a function f of x is a function f of x for a continuous random variable capital X is a probability density function if it satisfies the following conditions. One is f of x is for non-negative, that is f of x is greater than or equal to 0 for every x belongs to a real number set. And integral minus infinity to plus infinity f of x dx is 1. In the discrete random variable, summation of x from I to n or sigma x equal to xi to x, sigma summation is 1. In the case of this density function, integral minus infinity, instead of summation, you integrate f of x from minus infinity to plus infinity, that integral value is 1. Also, this in an interval, probability of a less than or equal to x less than or equal to b, if it is the case, probability density function defined interval a to b f of x dx. If it is an interval a comma b, x belongs to the interval a comma b. If it is the case, probability of a less than or equal to x less than or equal to b, it is nothing but interval a to b f of x dx. It's also the definition of a probability density function. Okay? Now, we will solve some problems in the topic continuous random variable and the probability density function. It is in the exercise in your textbooks 11.3. The problem is the probability density function of x is given by the probability density function f of x is given by f of x is k into x e power minus 2x for x greater than 0, 2x for x greater than 0, and 0 for x less than or equal to 0. So this is the probability density function given in the problem, and they ask you to find out the value of k. Find k, that is the problem. We know that the probability density function is by the definition for a probability density function f of x, we know that integral minus infinity to plus infinity f of x dx is 1. Here, less than 0, minus infinity to 0, function is 0. From 0 to infinity, the function existed. Therefore, for this problem, probability of x greater than or equal to 0 only, greater than 0. Okay, that is equal to integral 0 to infinity f of x dx is equal to 1 given. By definition, integral minus infinity to plus infinity f of x dx is 1. But in the case of minus infinity to 0, less than 0, left side function 0, right side only the function existed f of x. That is equal to, that is integral 0 to infinity f of x is k into x e power minus 2x dx equal to 1. Taking k outside, integral 0 to infinity x into e power minus 2x dx equal to 1. Well, you know the gamma integral 0 to infinity x power n into e power minus ax dx is equal to n factorial divided by a power n plus 1. This is the formula for gamma integral. N factorial divided by a power n plus 1. This is the gamma integral value. So from that I get k into x power 1, n is 1, therefore 1 factorial divided by a is 2, a power 1 plus 1, n is 1, 1 plus 1 equal to 1. 1 factorial is 1, so k into 1 by 2 power 2 equal to 1, that is k into 1 by 4 equal to 1, so k equal to 4. So that's all about the problem. So value of k is 4 only. Okay, that's all about the problem. In the next problem in the exercise, the second problem given, the probability density function f of x is given that x for 0 less than x less than 1. 0 to 1, the function is x. From 1 to 2, function is 2 minus x, and otherwise function 0. From 0 to 1, f of x is x. From 1 to 2, f of x is 2 minus x. Greater than 2, function is 0. Otherwise, out of that intervals, the function is 0. If it is so, find the probability of 0.2 less than or equal to less than 0.6. Second one is probability 1.2 less than or equal to less than 1.8, and probability of 0.5 less than or equal to less than 1.5. For a probability density function, I already explained integral probability of a less than or equal to x less than or equal to b equal to integral a to b f of x dx we have defined by the probability density function. In the definition, I have given that this is the probability for the probability density function for the interval a comma b. If it is so, for this problem, first one, probability of 0.2 less than or equal to x less than 0.6 is integral 0.2 to 0.6, 0.2 to 0.6. It is lies between 0.2 and 0.6, lies between 0 to 1, therefore the function is x only, x dx. Because in this interval, function is x. From 0.2 to 0.6, the function is x. So by integrating x, you will get x square by 2 from 0.2 to 0.6. Giving upper limit and minus lower limit, you know the definite value, x square is 0.6 square minus 0.2 square by 2. Okay, or 1 by 2 into, you can write this as, you can take 1 by 2 as a common term, x square upper limit 0.6 square minus 0.2 square. That is equal to 1 by 2 into 0.6 is 0.36 minus 0.2 square is 0.04. 2 to the 4, 0.04. Therefore, this is probability of 0.2 less than or equal to x less than 0.6 is equal to 0.36 minus 0.04 is 0.32. 0.32 by 2. So that is nothing but 0.32 by 2 is 16. So for this probability 0.2 to 0.6, the density function value is 0.16. Second one, probability of 1.2 less than or equal to x less than 1.8. So this is equal to 1.2 to 1.8. 1.2 is greater than 1 and 1.8 is lies between 1 and 2. 1.2 to 1.8 is lies between interval 1 and 2, therefore this is nothing but 2 minus x dx only. So this is 2 minus x dx only. For this is equal to integral 2 into x is integral 2 into integral dx, that is x, minus integral x is x square by 2. You have integral 2 constant, integral of dx is x, minus integral x is x square by 2. So limit is 1.2 to 1.8. So this is equal to 2 into upper limit 1.8 minus lower limit 1.2. First case. Second case, second integral 1 by 2 into x square is 1.8 square minus 1.2 square. This is equal to 2 into 1.8 minus 1.2 is 0.6 minus 1 by 2. 1.8 to 1.6 is 0.2. It is 1 by 2 into 1.8 square. 1.8 square is 3.24. 1.8 square is 3.24 and 1.2 square is 1.44. 1.2 square is 12 square 1.144, that is 1.44. 18 square is 324, that is 3.24. So 2 into 0.6 is 1.2 minus 1 by 2 into this is 0, 2 minus 4 minus 4, 0, 12 minus 4, 8, and 2 minus 1, 1.8. That is 1.2 minus 1.8 by 2 is 0.9. 1.2 to 0.9 minus 0.9 is 0.3. So second probability of 1.2 less than or equal to x less than 1 by 8 is 0.3 only. Okay? Next, third one is probability of 0.5 less than or equal to x less than 1.5. Third one. Next, we have to find out probability of 0.5 less than or equal to x less than 1.5. That is equal to integral 0.5 is 0.5 to 0.2 is here. 0.5 to 1 is f of x. You split this into two integrals. 0.5 to 1 in this case, plus integral 1 to 1.5. 1 to 1.5 in the second case. So the first case 1.5 to 1 is x. F of x is nothing but what? X dx. And 1 to 1.5 in the second case is 2 minus x dx. So this is integral x is, you know, x square by 2 from 0.5 to 1 minus this is integral 2 into dx is integral 2x minus integral x is x square by 2 from 1 to 1.5. Okay, listen. This is x square by 2, upper limit is 1. Therefore, you get 1 square is 1 by 2 minus 0.5 square is 0.5 square is 0.25 by 2 minus, in this case, you just apply upper limit first, 2 into 1.5 minus lower limit 1 minus 1 by 2 into x square is 1.5 square, that is 2.25 minus 1 square is 1. 1.5 square is 2.25 minus lower limit is 1. Here 1 minus 1.25, 1 minus 0.25 is 1 minus 0.25 is 0.75. So this is equal to 0.75 by 2. In the case minus 1.5 minus 1 is 0.5. 1.5 minus 1 is 0.5. 0.5 into 2 is 1. It is just 1. Minus 1 by 2 into 2.25 minus 1 is 1.25. 2.25 minus 1. 1.25. So you consider this 0.75 by 2. Okay. See here, x square by 2 plus is there. I'm sorry, the plus sign is there. So plus, here also plus. Okay. Therefore, 1 point plus sign is there. So 0.75 by 2 plus into 1 plus into minus 1.25 by 2 plus 1. You bring that plus 1 in there. This is 0.75 minus 1.25 minus 0.75 is what? 0.5. 0, 12 minus 7, 0.5 by 2 plus 1. It is minus sign also. It is a minus sign. Okay. So 0.5 by 2 plus 1. This is 1 minus 0.5 by 2 is 0.25. So 1 minus 0.25 is 0.75. So that subdivision probability of 0.5 less than or less than 1.5 is 0.75. That's all about the problem. Okay, I will stop the video here. We will continue the remaining problems in the next video. Thank you.